Okay, hi class. Today's lesson is on space again, but today we're talking about patterns over time. Patterns over time. So remember to smash that like button, hit subscribe. Let's learn about space. Okay, right. So shadow. What's a shadow? Starting off very easy. So shadow is a dark area caused by an object blocking the light. Okay. So you've all seen shadows before? You just all know what a shadow is. Great. Also, I hope you already know this. The sun rises in the east and sets in the west. Why? Because the earth is spinning. Great. Okay, so we're going to look at a time lapse of sun causing shadows. Okay, let's speed this up though because it's very slow. Okay. So I want you to try and observe what happens to the shadow. So I hope you'll notice that as the sun moved around the sky, or more correctly, as the earth moved, the shadows moved around the object. Okay. And also, as we got late into the evening, later in the day, the shadows got a lot longer. Okay. So when the sun is high in the sky, shadows are short. Okay. That's because there's a small angle. Okay. And when the sun is low in the sky, the shadows are long because the angle is large. See here? Again, very simple. Okay. And you've probably all noticed this before. I want to tell you about something cool. This is called Lahaina Noon. I think I'm saying that right. I don't know. Lahaina Noon. So this happens when the sun is exactly over the top, exactly above. And it stops objects having shadows, like these poles. There's shadows like under the car around here, yeah. But like these poles, there's no shadows. And it kind of makes things look like they're in a video game where you've got the settings turned down really low and there's no shadows. Yeah. The proper name is called the subsolar point, the under sun subsolar point. Okay. So everywhere in the tropics, yeah. So that's the area between these two lines, between the Tropic of Cancer and the Tropic of Capricorn. So this area of the Earth is called the tropics. Okay. So we're in the tropics right now. So everywhere in the tropics will have one of these Lahaina Noon 2 times per year, everywhere. Okay, and I used an online calculator and I worked out when the next Lahaina Noon will be in Ho Chi Minh City in Saigon. And it's on Thursday, April the 16th. What are the chances? So, on Thursday, when you have a look out your window, or if you're lucky enough to be allowed, go outside and have a look. and at 11:53, it should be around 11:53. The sun should be directly overhead, and there should be no shadows. So maybe you can tell me if that one worked. Okay, so we're going to watch a quick video, and this is to show you what's possible to work out without computers or calculators, or clever people back in ancient Greece. Okay.
How would you set about to measure the Earth with the mathematical knowledge and tools you already possess? A Greek named Eratosthenes did it 240 years before Christ. He was head of the great library of Alexandria in Egypt, a city built by the Greeks. He, like others, suspected that the world was round. After all, the sun and the moon were round. He had also noticed that the sun's rays fell in parallel lines. Greeks before him had divided the circle into degrees and had measured angles. With this information and a logical mind, he measured the Earth. Here is how. While visiting the city of Syene one midsummer's day, Eratosthenes noticed that the reflection of the sun could be seen in the bottom of a deep well. The sun was overhead, and the rays pointed to the center of the Earth. He remembered this, and on the next midsummer's day in Alexandria, he measured the shadow cast by an obelisk. Sunbeams travel in parallel lines, so the difference in angle had to result from the curvature of the Earth. If the angle was 1/50th of a circle, then the distance around the world must be 50 times the distance from Alexandria to Syene. With these simple tools, Eratosthenes made this almost exact measurement of the world more than 1,700 years before Magellan sailed around it. He was a friend of Archimedes. He was a mathematician and a poet, invented the sieve for finding prime numbers, was the first geographer, and corrected the calendar to the one we use today.
Wow. Very cool. So, anytime any of you complain about not having a calculator, look what you can do with that one. Amazing. Right. So, we're going to talk about stars and constellations. Okay, so the ancient Greeks used patterns in the stars to help them tell stories about mythical creatures and gods. Okay, so the Greeks had a very active imagination. So when they wanted to tell a story about Zeus or Apollo, any of the other Greek gods, they would use constellations to draw pictures in the sky. And constellations are just drawing lines between the stars. Now we use constellations to help us find particular stars in the sky. It's very hard to find a star if you're just looking at the sky. But if you can see patterns, then it's much easier. So this constellation here, made up of these stars, is called Ursa Major. Now Ursa just means bear, and Major means big or great. So this is the Great Bear. Okay. Now it's not quite as easy to see as this when you look up at the sky for real. You see? So just this part here is the brightest part. Okay, so look for this bit here. See, you can see it here. Okay. So we have a special name for this bright bit at the back. Americans call it the Big Dipper because they think it looks like a deep fat fryer. So that's what Americans like. And the English think it looks like a plow, which is a thing that you drag behind animals to help do farming. So yeah. So it's got lots of different names around the world, but it's very famous because it's very bright. Okay. And you might be saying, Mr. Charlie, why do I care about the Big Dipper or the plow? Why do I care about that stars in the sky? Well, I'll tell you. So, if you look at these stars here, okay, you can see them here. So if you look at the star that comes at the top right point of the Big Dipper, and then you look at the length from B to A, okay, and then you times that by 5, so 1, 2, 3, 4, 5, and we get this star called Polaris. Now, this star is very important. It's a very important star, Polaris. It's also known as the North Star. So, when you look at the night sky, as the Earth is spinning, you see all the different stars moving as we spin around. But one star does not do that. It just stays completely still as everything else moves around it. And that's because the tilt of the Earth, we talked about in the last lesson, the way the Earth is tilted, it's aimed directly at that North Star. Okay? So as it's spinning around here, we're aimed straight at that North Star. So it doesn't move. It's also always in the north. So useful. So if it's ever nighttime, all you need to do, find the Big Dipper, look at this distance here, times it by 5, you end up with the North Star, and that's where north is. Very useful. If you don't have a compass, you have a map. Oh, there we go. Little video. So that's the North Star here. It's also very bright, one of the brightest stars in the sky. Okay, great. So now you can find north at night. Well done. But there are other constellations. There are other shapes. You probably recognize these names because people who are born at a particular time of year call this their star sign. So, for example, mine is Scorpio. And the Greeks thought this looked like a scorpion. Yeah. Cool. So let's learn some more. So this one is Cassiopeia. So they thought this looked like a beautiful woman looking in a mirror. See, the Greeks had a very, very good imagination. Yeah. So to see these stars here, these 5 stars, and think it looks like a woman looking in a mirror. I don't know. Okay. And this one, Draco, because they thought this looked like Draco Malfoy from Harry Potter. No, not really, of course. Draco means dragon. So they thought this looked like a dragon. Or a snake, I guess. Dragon, snake. Yeah. Okay. So I think we talked about this very quickly in our other lesson, and you had a worksheet on this. So this is the different stages of the moon and the different names. So as we move here from new moon, that means you can't see the moon. And then we'll move around in this direction. We have waxing crescent, a first quarter, waxing gibbous, full moon, waning gibbous, third quarter, and waning crescent. Waning means going away. Okay. Oh, and one more thing. So before we had watches and clocks to tell the time, they used to use this, which is a sundial. So it's very clever. As the sun moves around, the shadow points at a different time. Fantastic. Okay, there's some extra videos. I'll put them all in the description. And that's it. Goodbye.